This video is meant to be a tack-on to 4.1 position, speed, and velocity. I'm going to call it 4.1 speed equation extra practice. You do have some learning goals for this. Those are, you need to make sure you continue to understand how to use the speed formula, and you're going to also make sure you get how to rearrange an equation. So how to take those letters within the equation, mix them around using algebra so that you can have a usable equation to solve a problem. We're going to do 3 problems today, solving for each of the variables in the speed equation: speed, distance, and time. And we're going to start with this one, basic one. What is the average speed of a car that traveled 240 miles in 4.0 hours? So, first thing you need to figure out is, what are you looking for? Again, sorry about the glare. I'll write to the side of it, just how the room is. So what are we looking for? What is the average speed? So V. V is what we are looking for. What are we given? We're given that the car traveled 240 miles in 4.0 hours. So our distance is 240 miles, and our time is 4.0 hours. Excellent. Now, what is our relationship? When you're looking for speed, it's pretty much straightforward. It's just the speed formula, which will always be given to you, so you can just write it down and just go with it. Speed equals distance divided by time. There's our relationship. Now, let's plug in and solve. Again, rewrite your equation. All right. Our D is 240 miles, so that's 240 miles. Our time, T, is 4.0 hours. So do 240 divided by 4. You'll get the number 60. And the units, as always, are going to carry down from what you see. So miles/hour become miles/hour. Box your answer. You're done. That is the answer to the first question. Now, for those of you who are in my Curriculum A level, I'm going to be putting the answers down in significant figures. So just note those and see what's going on with that. But I'm not going to go in depth into that because in my other classes we do not cover that. Okay, another problem. Our next one is one that will hit close to home. After winning the 2013 ALDS, the Red Sox get on a plane in Tampa and fly back joyously to Boston. Woohoo! Awesome. What they want to know is, how far away is Tampa from Boston? And they overhear the pilot say that their average speed is 630 kilometers per hour, and it takes 3.0 hours to get back to Boston. So putting the whole question up there, if their average speed in the plane is 630 kilometers per hour, and it takes them 3.0 hours to get back to Boston, how far away is Tampa from Boston? So what are we looking for? First, we're looking for distance, because it says how far. It's not always going to tell you distance. Sometimes you have to decipher it based on the words. So how far means distance. That's what we're looking for. What are we given? Pilot told us the speed, 630 kilometers per hour. Let's write that down. V equals 630 kilometers per hour. Always have units, always keep units, very important. And the time is 3.0 hours. Okay, so now we need to rearrange this equation, the speed equation, to make sure we have the correct alignment so we can proceed to solve the problem. I'm going to do that over on this sideboard. So we need to know how to take this equation right here and rearrange it so that we can solve for distance. So you're always going to be given this equation outright. Speed equals distance divided by time. So how do we get it so that d is alone on one side? Well, just like everything we've been doing with units and crossing out and dimensional analysis, this is going to work the exact same way. D's here times here. We want d so it's alone. We need to get rid of time. In order to get rid of time, what you have to do, because it's on the bottom of a fraction, you have to multiply this side by that variable. You're allowed to do this because it's eventually going to become a number. Treat these letters like they're numbers. You're just shifting them around. So remember that that's like it's over 1. So this side ends up crossing out on the t's. You're left with d over 1, which is just d. But because this side of the equation is equal to this side, whatever you do over here, you also have to do right here. So I also have to multiply that side by time, because they equal each other. And so what I'm left with is distance equals velocity times time. Distance equals velocity times time. If you just put two letters together, it counts as saying multiply them together. You don't actually have to physically put in the x or the dot. This works just fine. So let's go back to that equation. So now that we have that, d equals vt. That's our relationship. We plug in and we solve. Distance equals velocity times time. So we're going to say 630 kilometers per hour times 3.0 hours is going to equal to, so let's multiply the numbers. 630 times 3.0 is going to be 1,900. Again, I'm watching for significant figures for those who are in my curriculum A. Others, I'm just rounding, so you know. And what units do we use? Well, distance, you might be able to decipher that. Kilometers is in there, so we're going to use kilometers. But if you notice, you see how we have an hours on the bottom and an hours on the top? They cancel away. Everything's going to work like this throughout the year. Just keeps building, building. Same exact thing that we're going to do again and again and again, with things canceling and things moving around. So kilometers are a unit that gets brought down here. So Tampa is about 1,900 kilometers away from Boston. Our last problem is going to be solving for time. So let's look at that. How much time would it take a bicyclist to travel 50 kilometers at a rate of 0.25 kilometers per hour? So what are we looking for? How much time? T. What are we given? We're given that travel 50 kilometers. You should recognize that the km is units of distance. And a rate of 0.25 kilometers per minute. So see in that one, it doesn't say speed, it doesn't tell you that. It wants you to look at the units and figure out that km per minute, that's distance per time, that is your speed. So, your speed, 0.25 km per minute. All right, now, what to do? Let's go back over to the other board. Now this one's a bit more complicated because time is on the bottom of this fraction. So I can't outright multiply this by distance to get away, because if I multiply this by distance, I can't cross out the d's. I can't. So what I'm going to do is I'm going to take it 2 steps. I'm going to start by moving time back over to the side with the v, like we did in the previous one. Multiply by time, they're gone, because this side equals this side. I have to do it on the same side, and we find out that distance equals velocity times time. Sorry, speed times time. We'll get to velocity. All right, now this is more manageable. I want time so it's alone. Now I have to get rid of the v. So what am I going to do? because these are connected with multiplication, I'm going to remove the v with division. Up here, they're connected with division. I removed it with multiplication. So I'm going to divide this side by v. Crosses out. Whatever I do to one side, I have to do to the other. And we find out that time equals distance over speed. Nifty little trick. Look up here at the original one. Speed equals distance over time. You're allowed to, when it's like this setup, when there is one variable equaling a fraction with two other variables in it, to swap those two. You can't swap these two. It does not work that way. You can swap the one that's alone with the one that's on the bottom. See how that occurred right here? The v and the t just switched places. Let's go back to the problem. So that one's a bit trickier with switching stuff around, but use that trick I showed you too, and it becomes a little bit easier. Time is distance over speed. So again, we're going to distance over speed. Distance is 50 kilometers. Speed is 0.25 kilometers per minute. And what's that going to be? If you do 50 divided by 0.25, you get 200. And notice we have kilometers here and here. There is a math function that says if there's a fraction under a fraction, these units are allowed to travel to the top. But anyway, if you just recognize that there's 2 kilometers for now, and know that minutes is a unit of time, then you're in business. Takes the cyclist about 200 minutes. If you want to figure out how many hours that is, go ahead and use dimensional analysis and let me know later. So, those were 3 problems to help you get more familiar with the speed equation and how to rearrange the variables within the equation. We're going to keep using this in class. We're going to get to mess around with some carts and cars and measuring their speed and calculating a variety of things. So, see y'all in class.